So, this warm-up. Okay, so the instructions, all they said was write the equations for each function shown in the graph. Now, what I'm going to do is kind of take you through, you know what unit we're in, but let's say you didn't. Let's say this was the final or something. I just said write an equation for the functions, right? Well, the first question you have to ask yourself is, what type of function, right? Like, is this linear? Is this exponential? Is this quadratic? Is this logarithmic? Like, what are we dealing with here? Because without that information, how would you know what to plug into? How would you know what form to use? How would you know really where to get started, right? So you have to ask yourself in your mind, like, okay, what type of functions are these? And then there's a couple ways you can tell. So what type of functions are these? Exponential. How can you tell by a graph?
Go up.
It goes up. Does it go back down? No. Doesn't touch zero. Well, if it's shifted, but you're right, we never had one that did. It has a line that it doesn't touch, right? Just so you know, they could shift down and then it would be never touches negative or something, -2 or something. Also, it's not a straight line, right? So it's growing, but it's not a straight line, right? Or it's decreasing, and it's not a straight line. What about in a table? Right, it's multiplying over and over again. It's not adding, it's not subtracting, because that would be linear, right? So first thing you got to do in your head is check. And then you're like, yep, okay, exponential. Once you know it's exponential, now you know what you're dealing with. You're dealing with what equation? That's linear, right? So we're dealing with y equals ab to the x, right? Okay, so now I know I'm dealing with that. So now I know, okay, well, I always plug in for everything that's not y or x. So the two things I need to find in each of these situations must be what and what? A and B, right? So that's your starting point, right? You got to figure out what you're plugging into and what you're missing. Now you can go find it, okay? So we're going to go find it in each one, right? Now, to go find these things, well, you got to know what they are. Your A is your what?
Starting point.
Start. It's also your what? Oh, no, that's in a log. It's your y-intercept, right? Yes, the y-intercept is not the first point on the graph, but it's a good place to start, so we call it our starting point, right? And our B is our A is where we start, our B is what we multiply by to keep going, right? So it's our multiplier. Very good. Okay, so we just need to find that in each of these cases. Each of these cases will have a little bit different way of asking you, all right? First one is the classic graph. Now, we usually find our A first because it's just a point that we can just point to, right? So what's our y-intercept here? 1, right? Right there. So boom, we know our A, right? Halfway done. Now our multiplier. Now, some people can look at this graph and say, oh, that's multiplying by 4. Some people are like, I don't know how you saw that. I just see a line going up, right? So talk to me about how you see it.
We'll look at the next point.
The next point, okay, and that is there, and then the next point
is 16, and then we divide 16 by.
Okay, so you're still doing a little bit of work in your head. Here's the thing. If you still think that's a lot to do in your head, what can I create with these points? Yeah, I can make my own XY table. It's more work, but sometimes more work is needed, right? It depends on the person, right? For some people, this makes a lot more sense than that because now they see the numbers and they go, oh, it's multiplying by 4 every time, right? Times 4, times 4. So my B is 4, and my equation is y equals 1 times 4 to the x. But what's a simpler way to write that? Just 4 to the x, because 1 times anything is just itself. So, okay, we have done the equation. We have we've answered the problem. We've written an equation for the function. Now, what I want you to pay attention to here is kind of the backwards version of this, right? It's not being asked right now. But if you saw just this and I said graph it, well, now we know the a is 1, right? Sometimes that's not super obvious if we just have 4 to the x. Remember, there's always an imaginary 1 out front if there isn't an a value, okay? So that's your first version. All right, your next one is a table, right? Maybe a table where you need to find a and b. Now, what was nice about finding a in a graph, it was right there. It was our y-intercept. We just pull out the point. But we don't have that point in our table. What do I mean by that? There's no 0. We know a y-intercept always has an x of 0. So I was looking for an x of 0, but there is no x of 0. So what do?
You find the b first.
Yeah, I guess you could think about it that way. But why are you finding that b? So you can what?
So we can do the opposite of that to find 0.
Exactly, yeah. So when you're looking at a table, it's a snapshot of a bigger picture, right? It's like a picture of a mountain, but then there's trees over here, there's a valley over here, right? A table is just a snapshot. You can make the picture bigger if you want to. So we're going to go backwards. We're going to go up to 4, 3, 2, 1, 0. And then we know that this to go down was multiplying by 2. So to go backwards, we would divide by 2. 20 divided by 2 is 10 divided by 2 is 5. And now we have our y-intercept. We have our a value, right? So our a is 5. And our b is our 2 because we're multiplying by 2. Okay? So y equals 5 times 2 to the x. Okay? Now, third version of this problem, right? We have y equals ab to the x. We're trying to find our a. We're trying to find our b. We know that the a, when we have a graph, we just look for that y-intercept. But what's the problem? We don't have a y-intercept. So we kind of have to combine our skills here. What can I do to back into that number? Remember, a graph is just a snapshot. It's just a little picture. Yeah. Yeah, well, I would make my own table here, right? And I know I got to back it up to what? 0. So I got to go at least that far, right? And I add the good points that I can find, and then I'll back into my own table. So here's a good point, here's a good point, here's a good point, right? So what good points do you see?
3.
3 what?
10.
What else?
2, 20.
What else?
4, 5.
Okay. Now it's in that familiar table space. I can do the same thing I did over there. It's going down. It's what's happening?
Divided by 2.
It's divided by 2. So to go up, I would?
Multiply by 2.
So it would be 1, 40, 0, 80. I found my a. Now, this is the final skill that you might need here. When it's going up, it's sometimes very easy to see that multiplier. It's, oh, you just multiply by 20. Multiply by 2. Multiply by 2. When it's going down, first of all, if something's going down, what are you multiplying by? A fraction. Like, so that's a kind of a key that you're going to end up with a fraction here, right? And to find that, you have to ask yourself, well, 80 times what is 40? 40 times what is 20? Now, a lot of people can just see, oh, that's 1/2. Just the opposite of multiplying by 2 is multiplying by 1/2. Some people can't, right? So think about the question that you've asked yourself. You're saying 80 times our b equals 40, right? Because we multiply by the b every time, right? Right? We don't know the b yet, but we know that we multiply by the b. So how would I solve for the b here? 80b divided by 80, right? Now you don't have to do this every time, but it shows you what your math is here. You take any number and you divide by the previous number. So 40 over 80 reduces to 1/2, right? Now that's super useful when it's, what if it was like 7/8, right? That'd be really hard to just see in your head, but you could calculate it using this process, right? It's not always going to be as easy as 1/2, okay? Now, in all of these situations, we knew you were dealing with an exponential function. We already discussed this, right? If it's a graph, it's because it's curved and increasing or decreasing and not both. And if it's in a table, it's multiplying, or if it's in a graph, if you want to think about it that way. Multiplying a pattern. Okay? Now, the two pieces that we found in each scenario were A and B, right? Where A is our start, or y-intercept, and B is our multiplier. Now, I know that warm-up was review, but it was probably very good for upcoming tests if you weren't locked in on any of that stuff. And it's also really important that we understand the pieces for what we're going to do today. So what we're about to do next is new, okay? Now, any questions on anything we covered so far before we get started? Okay. Now, sometimes you get a whole graph. Sometimes you get a whole table. Sometimes you get a whole graph. Sometimes you just get that. And your notes are missing these boxes. I added these, I meant to add them before I got the copies. But it's actually okay. So what you should probably do is just add like little carets here so you can add in what we're going to put in there. Now, the way you got it, it might be the way you get it, right? Where it just goes from 1 to 3. Why do you think I added an empty box in there? To make it easier, but also to show you what's missing. What's missing when you jump from 1 to 3? 2. Right? So this is actually going to have a point in the middle. Now, if we're still trying to answer this question, y equals ab to the x, right? Well, we kind of need to know the pattern, and we are only given 2 sets of information, right? But we can think this through. So I'm going to teach you 2 ways to do this. The think it through way, which is the front of this page, and the it's too hard to think it through, which some of them will be, because they're not going to be they're not going to be mental math problems. They're going to be stuff you need to write out. But this is the think it through one, okay? Now, we know to get from one number to the next, you do what in exponential equations? You multiply. What do you multiply by? What letter?
B.
B. So we know whatever B is, to get to this number, we're going to multiply by B. And then, again, we're going to multiply by B. Okay? So think about this process. What we're saying is, if you take 6 and you multiply it by B, and then you multiply it by B again, you get 54. What is B times B?
B squared.
B squared. So this is really 6b squared equals 54. Can we solve that? Yeah, we could solve that, right? How would we get b by itself here? Divide by 6 on both sides, right? I get b squared equals 9. Yep. And then I square root both sides, and I get b equals 3, right? Which means this was multiplying by 3 every time. Now, if we're trying to do y equals ab to the x, we just found our b of 3. Okay? We could extend this table, keep going, et cetera, if we wanted to. Okay? Now, and so this would be 18. Okay. We still need to find our a. What do we do now that we know our b?
Divided by 3.
Yeah, we got to go backwards, just like we did in the warm-up. So I'll add a box here, right? And I go to 0, backwards 1, so I would divide by 3. And I go from 6 to 2. So our a is 2, and our equation is y equals 2 times 3 to the x. Now, that can work, but what if instead of being right next to each other, they were way apart? And what if your b was not 3, it was like 1.79 repeating, right? We need steps for that. Yeah. All right, so that is if we have a b that is pretty straightforward. Like some of you might have looked at this and just said, well, I know I got to multiply this something twice. Let me try 2. Let me try 3. Boom, got it, right? It's not always going to be that simple, right? So let's talk steps if it's not that. Oh, and before we do, let's talk about what was given here, because there's another way you could ask this problem. All they gave us was this and this. What are those? They're points, right? So theoretically, and this was structured, especially once I added the boxes, in a way to try to push you in the right direction of how to solve this. But theoretically, I could have just said exponential function has points 1, 6, and 354. Find me the function, right? That's the same thing. It's just asked without putting you in the right direction, right? So you could see this same problem worded this way, right? And you will on the back, okay? So on the back, let's talk about one that's worded quite like that. Okay, so here we go. It's an exponential function. So we know it's y equals ab to the x. That's important, right? Got to know what we're starting with. And it's going through these 2 points, 112 and 436, right? And that's all we're given, right? That's all we can tell so far is that it's going to go through those points. Now, we tried to back into the answer using some scratch paper, but we couldn't get it, okay? So we need steps, okay? Now, whenever we've dealt with 2 points before. There's been problems in past units where we had 2 points and that's all we had. And before we started, we said, let's label those points so we don't get them mixed up. How do we label when we have more than 1 points? Exactly. So this will be x1, this will be y1, this will be x2, this will be y2. Okay? And this process I'm about to give you will work for any 2 points that are exponential. Okay? What I'll do is I'll write the steps in this top box, and then I'll do a working example in the second box for each number. Okay? All right, so the first thing you want to do is create a y equals ab to the x equation with x1 and y1. What do I mean by that? Well, it's y equals ab to the x, right? So typically we plug in our a and our b in to get our equation. We don't know either of them, right? What were we given? We were given x's and y's. Well, we're going to work with what we got. We'll plug those in, right? And we're going to start with x1 and y1. So instead of y, I'm going to say, this is my equation. I'm plugging in what I got. All I got is x's and y's. So instead of y, I'm going to plug in 12. I don't know a or b, so I'll say ab. And then instead of x, I'm going to say 1. Okay, at least we're working with something now. Now, in this case, it won't always be the case, but we can simplify this because b to the 1 is b. So this is really just 12 equals ab in this case. It won't always be. Sometimes it'll be b squared or something. Okay, that's step 1. And by the way, I'm going to give you this really broken down. You're going to be able to combine steps when you do this on your own. I want you to really understand it, but it's not always going to take you 6 steps, okay? Step 2, you're going to solve for a, okay? Now, usually when we solve, we're finding a solution, something that makes it true. But when you have more than one letter, like we do in this equation, we can't actually get an answer. All we can do when we solve is get one of them by itself. So we're going to, all I mean by that is get a by itself. It's called a literal equation. It's the best you can do when you have more than one variable. So if I have 12 equals a times b, and I want a by itself, what do I need to get rid of? What needs to go away? B. So I divide, because that's the opposite, right? Divide by b, and I get a equals 12 divided by b. Okay? Now, that's as far as I can go because I don't know what b is, right? So I'm done. That's a, right? That's what we know a to be so far. Okay? Now, put that to the side. Hang on to that for a moment. Step 3 is create a second y equals ab to the x equation with, what's the piece of information we haven't used yet? x2 and y2. So that looks like this. 36 equals a times b to the 4th. Okay? Now, the reason we haven't been able to find a and b so far is every time we had one of them, we had the other one. You can't solve for a letter if there's two of them, right? But when you have two different relationship definitions, two different formulas, you can combine them. It's a little bit like a system, right? And you can use them together. So, if this says 36 equals a times b to the 4th, well, if we knew what a was, we could solve for b. What is a? 12 over b, right? Do we see that? This is a, so this can go right here, right? It can go right in a's place, and that will accomplish something for us. So the next step is plug in your a from step 2 and solve for b. Okay? So that means this goes in right here, and I end up with 36 equals 12 divided by b times b to the 4th. Now, again, I want to make sure it's clear why we did that. The only letter I see left is what? B. When you have one letter, you can solve, right? We'll figure out how to do it, but at least we know we can, okay? Now, to begin solving this, I would think to myself, okay, how do I start simplifying over here? When I have b to the 4th times a fraction, what would be helpful to put b to the 4th over? Yeah, and you can do that in your head. You don't have to write this, but essentially the top would multiply and the bottom would multiply, right? Multiply across with fractions, and you'd end up with 36 equals Yep, 12b to the 4th over b. It sure does, because that's b to the 4th over b to the 1. See, all our skills are coming into play here, right? So that's just 36. Yep, equals 12b to the 3. And y'all know how to solve this, right? So what would I do first? Divide by 12, divide by 12. I get 3 equals b to the 3rd. And then I would need to, how do I get b to the 3rd just be b?
1/3.
Raise this to the 1/3, or take the 3rd root, whichever you prefer, right? So I'm going to raise this to the 1/3, raise this to the 1/3. You need your calculators because your b is, yeah, about 1.44 rounded off, right? So again, that was never a b you were going to be able to do in your head in a table, right? You're always going to have to pick up a pencil for this one, okay? 1.44. I certainly couldn't do that in my head, okay? Now, we found b. What have we not found yet? A, right? So we're going to plug in b to find our a. Now, what would be a good equation to plug into? I haven't heard it yet. Go ahead. Yeah, go ahead.
You changed 12b to the fourth to 12b cubed.
It was 12b to the fourth divided by b to the 1. B to the fourth over b to the 1, you would subtract. 4 minus 1 is 3. Yeah?
Would the new equation be any of the missing x values equals a, b to that?
It's like a equals.
That's more work than we even need to do.
Isn't it a equal?
Yeah. Look, we're trying to find a, right? Do we have any equation on our paper that has a by itself already? Yeah, right. It's in step 2, right? And that's always going to be the case, right? You found a. A equals 12 divided by b. You just never knew what b was. Now you know what b is. Plug it in, enter, right? No reason to solve for a again, right? So if a equals 12 divided by b, well, our a equals 12 divided by 1.44. And so our a equals 8.33. Okay, so why do you think there's another step here?
Find the missing variance.
To put like the whole equation.
Yeah,
together.
so there's so many times where students do all this great work, and what did the question ask us to do? Write an equation. We found all the pieces. Let's write the equation, right? Write the y equals ab to the x equation. All right, so that would be y equals 8.33 times 1.44 to the x. And there you go. And that is the very last skill you will learn this unit. Okay? Now, right before I hand out your homework and let you get going, how do I know I did that right? Because there's a lot of steps there. What could I do to check my work? Plug in what?
Like some random number. Oh,
Not random number.
Points. Yeah,
This
4,
number or this number. If you plug in 4 to that x, what should you expect to get?
36.
36 or like 35.9999.
Because we rounded it up.
35.8, something like that. Why? Why didn't we get exactly 36? We didn't do anything wrong. We rounded a couple times, right? So that's always going to happen. Don't feel like you didn't do it right, right? You just want to get super close to it, and then you're like, okay, I got it. All right. Questions? Good job. Y'all nailed that.